This is 8.5, and what we're going to do here is we're going to be solving some equations again. We did this back in 8.1, but these are going to be a little bit more complicated, but the same principles really apply. The thing that's going to get a little bit more challenging is actually isolating our functions. So what it does is, and the reason why this is challenging is it's really tying in some of the things we did in 8.4 to simplify our functions so that way we can actually solve our equations. And once we solve, remember when we solve an equation we use the inverse trig function for the most part or special right triangles, but that means that we will get usually two solutions for every rotation around. So that's what we're going to kind of get into. So let's just get right into these examples. So we have 4 sine squared of theta equals 3, and it gives us the domain, which means the 0 to 2 pi means one circle around. So you can assume that there might be two solutions here. So the first thing we do is, of course, we're going to get rid of this 4. We're going to divide by 4 on both sides. So we're going to be left with sine squared of theta equals 3 over 4. Well, then we need to get rid of the square, so we have to take the square root of both sides. Now, normally, it would be plus or minus square root over here, but because our domain is just from 0 to 2 pi, the minus isn't going to matter here. So that means we are left with the sine of theta equals the square root of 3. So I did the square root of 3 is just square root of 3, and the square root of 4 is 2. So square root of 3 over 2 is actually a triangle that you should be familiar with. So if we do, our theta is right here. Opposite of that is the square root of 3. The hypotenuse is 2, which means down here is 1. So therefore, what we have here is we have an angle, because the opposite is square root of 3. This angle right here has to be 60 degrees. So because it's 60 degrees, we are going to convert that to radians, and 60 degrees in radians is pi thirds. So our first theta value here is pi thirds, and then again recall what we did back in section 1. We know that the sign is positive here, so where else is our sign positive? Well, here's our first one where we had pi over 3. Here's our second one over here where we have our reference angle is still pi over 3. So to get our second angle, we have to do pi minus pi over 3. So we do 3 pi over 3 minus pi over 3 equals 2 pi over 3. So 2 pi over 3 is our second answer, and those are the two answers that we have for this actual function. And again, the point is it stays the same once you get down to this. It's going to be exactly the same as it was before from 8.1, where you're going to get two answers. The first one, if you're using a special right triangle, then use a special right triangle. But if it's not a special right triangle, then you're going to use your inverse function on your calculator. And then, of course, you're going to find your other one doing the same methods, figuring out which quadrant you're in and then subtracting it from pi or 2 pi in that case. So that one was an easier one. Let's do one that's a little bit more difficult. This one can be a little bit tricky, but again, we have to kind of think about how we're going to simplify this. So right now what I look at is we have a sine and a cosecant. So it's really impossible for us to break this down into one individual trig function when they're not the same. So what the goal is here is we first want to change this. We want to change this so it's in terms of sine. So we're going to rewrite this. That's our first step. 2 sine of theta minus 1 over the sine of theta equals 1. So now we have an issue here. So again, if we're going to try and isolate sine, we've got to clear the bottom of sine. So then what we're going to do that is we're just going to multiply every single term by the sine of theta. So what we do is we end up with 2 sine squared of theta minus, when you multiply sine by 1 over sine, that's just going to give you 1. And then 1 times sine of theta is sine of theta. Now this may seem weird, but here's the deal. We have basically a quadratic. So we're going to bring everything to one side. We have a squared function, we have a normal function, and then we have a constant. So we're going to bring the sine of theta over here. So we will be left with 2 sine squared of theta minus sine of theta minus 1 equals 0. So what you want to look at here is, and I know this can be difficult for some of you, but imagine your sines being a variable. So if my sines were just a variable, this is how this would look. It would be 2x squared minus x minus 1 equals 0. And then we would go through and try and factor this. And if you factor this, you get 2x plus 1, and you get x minus 1. And then you could solve. But we're not solving for x here, but it's going to be the exact same thing. If it's 2x plus 1 and x minus 1, then what's going to happen down here when we factor is it's going to be 2 sine of theta plus 1 and sine of theta minus 1 equals 0. Okay? So let's talk about this now. This becomes a little bit tricky, but what I want to do is I want to separate this into two separate things. Remember, the idea of factoring is to figure out if this whole thing equals 0, then that means everything's equal to 0, and the same thing for this. So we are going to have two equations here. We're going to have 2 sine of theta plus 1 equals 0. That's one equation. And then our other equation is going to be the sine of theta minus 1 equals 0. So now let's solve each one of these. This is going to be, make sure I keep it in the same color. So this one's going to be 2 sine of theta equals negative 1, which then means we have sine of theta equals negative 1 half. So that's the first one we're going to have to solve. The other one, we're just going to add 1, so we have the sine of theta is equal to positive 1. Okay, so we can solve each one of these individually. So again, we are between 0 and 360 degrees here. So where is sine of theta equal to 1? Well, hopefully, remember, sine is the y value, and the y value will be 1 at 90 degrees. And that's the only place that it will actually work there. So that's our only answer for this one because it was equal to 1. It will only equal 1 one time between 0 and 360. Now as for the other one, where is sine of theta going to be equal to negative 1 half? Well, again, what we do is we can draw a right triangle here, and here's theta. Here's our 1, because that's opposite. Here's our hypotenuse, because that's 2. And then this would be square root of 3. And hopefully you can figure out that your reference angle, at least here, is going to be 30 degrees because it's opposite of the 1. Well, if it's 30 degrees, what you need to do is you need to go to your quadrants. Remember, the sign is negative here. So sine is negative down in this quadrant right here and down in this quadrant right here. And we know that the reference angle is going to be 30 degrees. So if the reference angle is 30 degrees, my two angles are going to be 180 plus 30, or 210. Again, I got that because you go a full 180 degrees and then another 30. And then the other one is going to be 360 minus 30 degrees, so 330 degrees. So these are the four solutions to this. Once we factored, we had one equation to solve, got two solutions. We had another equation to solve, got one solution, so 3 total solutions there. So below here, this one is a little bit easier than the one above. The only thing that you want to make sure you're paying attention to is knowing what sine over cosine is and how to manipulate that. So try this on your own. I'm not sure how you guys will do, but it'll be interesting to see, and then we'll go from there. So on this one, what you should have done is you should have divided by cosine first. You would have gotten 4 equals sine of theta over cosine of theta. Sine over cosine is the same thing as tangent, so you have 4 equals tangent of theta. To solve for that first angle in radians, we do the inverse tangent of 4, which got us 1.326. That created a reference angle of 1.326. The other place where tangent is positive is the bottom left quadrant, the third quadrant. Again, that has a reference angle of 1.326. So we do pi. Remember, pi is right there, plus an additional 1.326 to get our second angle. So you should have gotten 1.326 as your first angle and 4.467 as your second angle. So hopefully that made a little bit of sense. This was a little bit of an easier one than above. We will continue working on this in class. So on the back of your notes, what we're going to do is this is going to be your do now when you get to class, and we're going to talk about that more. This is a pretty difficult problem, and it's going to be more like what we did in the second example. So save this for class, and this is what you'll work on as soon as you get into class. If you want to do it before then feel free to do that. So I will see you then.